Here in my hands, I have 3 boxes of piston rings. Allow me to demonstrate that each of these 3 boxes has been completely untampered with. As you can see, the seal is not broken anywhere. This is as bought from the store from a reputable manufacturer. Our first box is Toyota 2E engine piston rings, and this is sort of your engine from the late 80s, most of the 90s, many different Toyota models. Our second box, again, as you can clearly see, the seal is intact, everything is intact, untampered with, and this is your Toyota 3ZZ engine, which is your very late 90s, most of the 2000s. Again, many different Toyota models, Corollas, you name it. And our final box, again, as you can see, completely untampered with, is your Toyota 2ZR FXE engine. It is still in production, and the box, as you can see, as I already said, untampered with. What I'm gonna do now is that I'm gonna get my very crude but very effective ring tester, which I have made from scrap wood in my garage, but it's going to allow us to place a ring in this little vise, and then we're gonna measure how much mass or force is needed to be applied on the rings from these boxes to get them to close, to get the ends of the rings to meet. And here we have our results, and let's analyze them very quickly. We can see that we have a reduction in piston ring rigidity, tightness, tension, whatever you want to call it, of 5% in the first compression ring between the 2E and the 3ZZ. To be honest, this is a very crude device. This is not lab quality, obviously. So I don't think this accurately measures 5%. What it does is that it detects these large differences. As we can see, the second compression ring in the 3ZZ has 41% less tension compared to the 2E, and we have a 31% reduction in the oil control, the bottom, the third rings. In the 2ZR, we have a reduction in tension in both the first and the second compression ring compared to the 2E engine. And honestly, the oil control rings were not measurable. I did not put any numbers because this alone was almost closing the gap on the oil control rings. The oil control rings on the 2ZR engine are the loosest, the flimsiest rings I have ever held in my hand. To be honest, I have never held the piston rings of something so modern in my hand. So these are the numbers. What do these numbers tell us? They tell us that the less tension there is in a piston ring, the less rigid the piston ring it is, the less pressure it's of course going to exert on the cylinder when we put it in the bore. The less pressure the ring exerts on the cylinder, as the piston goes up and down, the less friction we're gonna have. The less friction we have, the more efficiency and power and whatever we're gonna make. Basically, this is how manufacturers over the years, this is of course just one of the ways, but one of the very important ways of how manufacturers have been meeting emissions and efficiency standards over the years. They have been reducing progressively the tension of the piston rings. However, reducing piston ring tension is not something that manufacturers really talk about. When they present a new generation of engines, a new vehicle model, a brochure, news article, wherever, they're really not going to mention reduced piston ring tension, although they have been doing it, as you can see, progressively throughout the years. Toyota, an example of reliability, included, and everyone else included. As you can see, sometimes in the 90s, we have reduced piston ring tension, But engines were very reliable in the 90s. If you take a Toyota or any other Japanese engine from the 90s, the sort of practice and pretty much common knowledge is that these engines do not consume oil. Between service intervals, the service interval, let's say, is 10, 12, 13, 15,000 kilometers. You're going to top up your oil, and then the next time it's time to service your engine, the oil is going to be either at the very same level or just slightly below, so the engine will have consumed pretty much zero oil. And that is because what technology can do realistically and reliably has been achieved sort of in the early 2000s. And beyond that, we are pushing things beyond the limit of what technology can reliably do. Allow me to explain. To have a piston ring with a lower tension and still have no oil burning within the engine, the first thing you're gonna have to change is your crosshatch pattern machining in the cylinder. A piston with very high tension can deal with very coarse, let's call it coarse machining, where you have large and deep spaces between the lines of the cross-hatching of the cylinder, and we're going to be able to have large amounts of oil pooled in these spaces in the cylinder. But a piston with a big tension, with a lot of tension, is still not going to burn any oil because it's going to apply a lot of pressure, and this pooled oil in these cross hatches is not going to be an issue, and so the engine is going to have a lot of space to wear and to be reliable, and it will capably do hundreds of thousands of miles or kilometers. When you reduce your piston ring tension, you now have to change your machining strategy. You're going to have to make a much finer crosshatch pattern with less depth because you want to prevent large amounts of oil pooling in the spaces of the crosshatch. If there's too much oil pooling anywhere, then your low tension piston ring will not be capable of controlling this, and oil will go past it into the combustion chamber where it will be burned. Having a high tension first compression ring and a low tension second compression ring is a compromise, a reasonable compromise between friction and sealing and efficiency and oil consumption. We use the first compression ring to seal the cylinder and prevent blow-by, and we reduce the compression on the second ring because we want to reduce friction a bit. This works, it has been used extensively. If we reduce the tension both on the first and the second compression ring, and then not only reduce the tension on the oil control rings, but completely redesign the oil control rings. As you can see here, we have the oil control rings of the 2E and the 3ZZ. As you can see, a very similar design. And then compared to the 2ZR, we have a completely different design. There are no more two rings, oil rings. We now have a single oil ring and an absolutely miniature little spring that is supposed to make this somehow not consume, the engine not consume oil. So if you reduce all of this, you enter a territory of very, very low tension, and you're going to have potentially high oil consumption. So you can make a very fine crosshatch pattern to have minimal, absolutely minimal oil pooling. You can even go to a plasma coating of the cylinders or another kind of bore spray coating that creates very microscopic little spaces where the oil can be. You have absolutely minimal space to prevent any kind of oil pooling, so you can minimize your oil consumption, and you can simulate all of this in your engine simulation software, and you can say, okay, this is gonna work. However, this cannot reliably work over hundreds of thousands of different engines and over hundreds of thousands of usage scenarios of different conditions and different consumers. A simulation is as accurate as the number of variables. And if we have only few variables, then the simulation can sort of say, okay, this engine is not going to consume oil. But the more variables we have, the less accurate the simulation, and in the real world, there are a lot of variables, which is why we keep some safe space, we leave a margin for error by having a high tension at least on one of the rings. Here, there is no margin for error. The machining has to be absolutely perfect. But as we know, it is impossible to keep everything absolutely perfect on every engine and over hundreds of thousands of kilometers. And this is why the latest engines from pretty much all manufacturers burn oil. And manufacturers are actually putting this in the owner's manual. If you go out there today and buy a brand new car, in the owner's manual, it's gonna say the car is gonna burn some oil. In the 90s, in the 2000s, this was not written in owner's manuals. If it was written, it was mentioned in a fashion in which it suggested that if your engine burns oil, a significant measurable amount of oil, then something is wrong with your engine. Because engines are not, four-stroke engines are not supposed to be burning oil. They're not two-stroke engines which have a total loss oiling system by design. They burn oil to lubricate the cylinder. But nowadays manufacturers are going to say something, and this is sort of the average over many different manufacturers, is that anything up to 1 liter per 1,000 kilometers of oil consumption is acceptable. Maybe I'm crazy, but to me, this is not acceptable. Why it's not acceptable is, let's take the 2ZR FXE engine, which has an oil capacity of 4 liters. Let's say that your engine consumes 0.8 liters per 1,000 kilometers. So it's below the threshold. It's a normal engine according to the manufacturer, according to the factory and the owner's manual. That engine will consume all of its oil. It's gonna burn 4 liters of oil. And your service interval nowadays is almost always 15,000 kilometers. That means that the engine is going to burn all the oil and destroy itself before it reaches the next service interval. What's even worse is that these numbers, 1 liter per 1,000 kilometers, were written in owner's manuals in like 2015, 2016. If you go to Toyota's website now and open a owner's manual of pretty much any car, and this is not just Toyota, pretty much all the other manufacturers have a similar or the same strategy, and you open the service manual, it's going to say that the car will, it's no longer questionable, the car will consume some oil. And they're going to say something like a certain amount. But nowhere in the manual you will be able to find what that certain amount is. Is it 60 liters? Is it 1 milliliter? It's not, it's a certain amount. Why it's left undefined? It's left undefined because in the past, manufacturers were forced to replace many engines because owners could easily prove that their engine is consuming more than 1 liter per 1,000 kilometers. And of course, that was an added cost for manufacturers. So what the manufacturer did is that they put this, which is a very bold, red-lettered claim: regularly monitor your oil level in your car. Keep an eye on it so your engine doesn't blow up. So why are manufacturers doing this? Before you jump to the comments to type planned obsolescence, let me stop you there. I see it's a really popular term nowadays, planned obsolescence. Whenever something fails, everybody is now using planned obsolescence. And yes, I'm sure there are examples of planned obsolescence out there, many examples. This is not one of them. This is not planned obsolescence. Planned obsolescence is making something fail deliberately at a certain time so you could increase ultimately your profits or guarantee your profits. This is not done because this is not a reliable way of planned obsolescence. Manufacturers have no idea, they cannot reliably, using this specific method, guarantee when an engine is going to fail, okay? It depends on the consumer. There's too many variables to make this good planned obsolescence. There's far easier ways to achieve good planned obsolescence, and manufacturers are doing it. This is not one of those ways because too many variables. What this is manufacturers have to do this because of modern emissions and efficiency standards, and it's very obvious. As emissions and efficiency standards have been increasing, so has piston ring tension been decreasing to meet them. The problem, I believe, is at these emissions standards, at these emissions and efficiency standards. Before you think that I'm some sort of person that believes that we shouldn't have emission standards and that I'm anti this and that I believe that, we should all drive carbureted PCV into the atmosphere engine, I'm not that person. I am a petrol head, I am a car guy, motorcycle guy, whatever you want to call me, but I believe that we should have emission standards and efficiency for engines. I believe they should be improving, they should be increasing in their stringency. I believe I like clean air. Everybody else, I hope, likes clean air. So I think we should have these standards. But what I do believe about these standards is that they are hypocritical. They're two-faced, they're dishonest, they're unrealistic, whatever you want to call it. Because what they do is that they take all of these standards, EPA, WLTP, you name it. They take a brand new, just broken in engine and they put it on their test cycle, test course, whatever you want to do, and they measure emissions, efficiency, and everything. And of course, a very fresh engine is not going to be consuming oil because it's easy to achieve. Whatever manufacturers are trying to achieve this, it's easy to achieve that tiny little margin of error when you have almost no variables. The engine is brand new. It has not yet been faced with the variables of the real world. And you get no emissions from increased oil consumption. However, as the engine ages, we get more variables and many engines start consuming a lot of oil. I believe that these engines with 20, 30, 40, 50, 60,000 kilometers or miles would never meet the emission standards that a brand new engine does. Yet we base everything on brand new engines. And manufacturers are allowed to legally put in their owner's manuals to say that the engine will burn a certain amount of oil. If we are legally allowing this, then we might as well legalize two-strokes on public roads again, because they also burn oil. It's fine, right? Because a car that burns 4-5 liters of oil between two service intervals is not that far from a two-stroke. So what I believe that the emission tests should do, and that would be fair towards both consumers and the environment, and I believe everybody else involved, is to have two engines tested. One engine is as before, as it is now, brand new, just broken in. And another engine can be an artificially aged engine to a certain number of kilometers. And that number can be whatever scientists agree upon is the most fair number, 60,000 kilometers, 80, 100, 40, doesn't matter. You put the engine on a test bench, you virtualize, you simulate a usage cycle, and you let it run for a month. And it's going to have non-stop for that time, and it's going to have your number of kilometers on it. And then take those two engines and test them both the same way. And there must be a maximum allowable difference in emissions and oil consumption and fuel efficiency and power and everything between these two engines. If the difference is above that limit, that engine should not be allowed on the market. Because engines in the real world are used. We can have the most fuel-efficient brand new engine on the planet. But that engine is actually, in the long run, doing more damage to the planet and to consumers than a horrible ancient engine from the 90s. Because that old engine may not be as efficient when it was brand new, but it is not burning as much oil. And burning oil, as we know, is a very significant source of emissions. That's it. That's all I wanted to say. Pretty simple message, but something that I think needs to be put out there. And I think someone who has decision-making powers over the bodies of government that control emissions and whatnot should advocate this approach. It is not a significant increase for manufacturers, but I believe it would serve everyone.